Good evening, and please let me know I am audible, all of you.
Yes, sir. Audible, sir. Good evening, sir.
Good evening. The content which we want to cover in the today's session already I share in your WhatsApp group along with I upload all these on the platform where you have registered. Okay. Some of the participants are facing some problem, but I will share the small recorded lecture, how you can sort out later after the session. So the today's session will be based on yesterday, which we cover some loops, logical statement. Okay, and in the today's session, some workflow in the MATLAB along with some functions, how you can use these conditional statement to write a program in the MATLAB. Also, we will cover during the session symbolic mathematics. Okay, so the stuff for today's session is very huge, but I'm not sure all the content will be covered or not, but don't worry, we will not run the course. If some content will due, I will provide either the recorded lecture or we can have a special session for the same. Okay. So first, I would like to share my screen. And before starting the session, if you have any question, uh, please feel free to ask from me. Any question, please, from your side. And also, as I told yesterday, if you have any problem related to the content or your query you want to ask from me in the form of a solution, you can send me your problem in WhatsApp group or either you can personal chat. Okay, so that in the coming session we can solve your problem along with some one participant asking yesterday some books related to the Scilab. I also share some books which are very basic content for the beginners who wanted to start Scilab in the course or need some help regarding Scilab. Okay, so the beginner for the beginners, this content which I upload in the WhatsApp group, I am sure will help you. And if you have a problem, you can contact me anytime. Okay, so this is my screen. And on my screen, you can see this is my MATLAB window. Okay. And I have to start from this. These are the today's content which I would like to cover. So yesterday we discussed about for loop, nested loop, and while loop. Okay. So based on these three loops, we have some mathematical functions or how you can write mathematical function by using these loops. Okay, loop play very important role to write some specific function when we have like a series type function. Okay, and sometime we have the functions based on some condition. Okay, just like piecewise continuous function. When you want to write piecewise continuous function in MATLAB and you want to visualize the behavior of the function, okay, then you need conditional statement along with the loops. So all these type we will discuss here. In this script file, we have the conditional statement. Okay. So first we would like to check this file. I have prepared all the script file so that we can save our time. Okay. Just 1 minute. I want to cover first for loop based function. Okay. Close it. So you can easily download all this file and select the file, then enter. This will open in your MATLAB. Okay. So here we have 3 examples. In the very first, we are using for loop. Okay. By using the for loop, how we can write a function and then how we can visualize its result and numerical values. Quite interesting. Is first we need to define range for x value. Okay. And we are choosing the x value range from 0 to 2 pi. With increment, you can see this is the increment 0.1. Okay. So interval starting from 0 and this is 2 pi and this is the increment or the length of each subinterval is 0.1, or the value of dx, you can say the value of dx or the value of h. So now after that, what you will do, and we will check all these things also one by one so that it will be very clear to all of you. Yes. So you will copy from this place and paste here. So you can see this is uh, sorry, this is one array. Okay. For x value. Then you will initialize an empty array to store the y values. So the purpose of this is just to write an array. Okay. The length of this y array will be same as we have this one. Need to understand this part. So when you will execute this statement, C, copy and paste in the MATLAB in the command window. Okay. And enter. I just enter and we can check from the workspace. So here you can see the length of x value and length of y value are same. When you will click on x value, these are the corresponding values of the same interval. Okay. And when you will click on it, you can see that the length are same, but all the values are 0. This is an empty array. Okay. Close it. Note this point, y array is empty at this place. So just we need to initialize to use this array for our function. And how we can use? See here. At this place, we are using for loop. Okay. So I will start from 1 to length x values. We are using length x values. So these are the x values. And you know, the length of x value we have is 63. Okay. So this will calculate automatically by using this length function. This is equal to 63. So if you will divide if you are making it more small by using 0, and at this place we have 5. Okay. So this will be a length more small, and the number of element will be about twice of 63. Okay. So corresponding to this array automatically will be updated, but all the values will be 0. Now, when you will initialize the for loop for the sine function, first we are using only sine function, which is inbuilt function. Later on, you can use for user-friendly function. Okay, you can write your own function, then you can call this function at this place. There is no difference. So the loop for this interval will start from the very first initial value. This one is not the initial value, this is the index value. Okay, the first value of for this X array is 0. But here, what is 1? What is the meaning of 1? 1 is index for 0. Okay, 0 is the first value. Then second value, third value, fourth value, and the last value. So this is the last value. So all these values will be taken from this array. Okay, so if it will be 1, then this value will be passed at this place. Okay, and also one more thing, all the values corresponding to this array, we need to store it someplace. Okay, where this value will be stored after calculating, this is the y value, and we want to store in the y value. How you can save? This is the y value I. Okay, so what is the purpose of this statement and how it will work? See, when you have I is equal to 1, it means this is the value of x1, and value of x1 is 0. Value of x1 is 0, that will be passed at this place, and sign 0 will be value of y corresponding to the index 1. Okay, so the x1 is equal to 0 and y1 is also equal to 0. Okay, then after y, I will choose the next value, which is 2. Okay, and corresponding to index 2, the value from this place will be taken, which will be x2 is equal to 0.05. This is the next value. Okay, and that value will pass through at this place, and the value will be calculated uh, for the sine function. That value will be stored at this place for y2. In this way, this loop will work until this last value. Okay, and corresponding to the entire index. When you will execute this statement, okay, see, I run this place, run from this place. Yes, close the graph first. You can see in the x value, we have now 1 by 126. Okay, so these are the size of x values, and this is the size of y values. Okay, previously it was 1 by 63, but later on we make more small the value of increment. The value of dx here is small as compared to the previous value. That's why we have the number of index has been increased 1 to 126. Okay, and also previously the values of y all were 0, but now check it. Now these values are not 0. Now these are the values which are simplified corresponding to each index of x. Okay, and the length of this array as well as the length of x array, both are equal. And the most important thing is now you have database. The database has been created at the place. You will select this one and this one. Then after you will go to address place, and when you will click on plot, you have the graph for the same function. Okay, this is the graph for the same function which you write at this place, and also you can use the plot function. Here is we have the same plot function. First we need the value of x, then we need the value of y function, and title, x label, y label, and grid on. All these are same thing which we discussed in the very first on the second lecture. Okay, when we discuss about the 2D plot or 3D plot, okay, all this the part for plotting is the same, and for different purpose we will manipulate according to our desire. Okay, so this is the corresponding values which you can see here. Okay, so the two things here you need to understand. One is X array, which usually we choose. Then we need to generate an array which is empty to store the value of y. And store the values of y will be simplified or calculated by using the for loop. Okay, so this is the use of for loop. And one more thing, this value, which is dx, will be as small as possible. We have more accurate numerical results, numerical graph. See, if I choose at the place, uh, I am choosing here only 1, okay, and I am executing the, and you can see the graph. You can see the graph pattern. Okay, so you can see at this place we have straight line, then we have the next straight line, and in this way. So this is because of this increment. So increment will be as small as possible. We have more accurate graph. So here you can choose 0 2, and then we have, now you can see the difference. So the increment must be as small as possible you can choose, but sometimes we choose too small. But you can see here the interval is from 0 to 2 pi. If you make this one, so what will do this one? Only complexity will be increased. Okay, so the you when you are thinking to about the increment, that also depends upon the interval, how small is your interval. But here we have 0 to 2 pi interval, so you need not required to choose this small value. If you have the interval like this one, see, if you have the interval like 0.001, okay, then you need to choose more small, okay, because the interval, as you can see at this place, is very small. Okay, and once you will write the program, you can do different type of experiment for more and more and more understanding. Just you need to manipulate. You can study the behavior. Okay, for this interval, the interval is very small. It looks like a very straight line. Okay, so you need to increase the interval. Now I have 0 to 1, and you can study the behavior. Now this is the interval 0 to 1, and there is a small bend in the line. And as much you will increase the value or interval. Okay, so now the curve is appeared in this way. And when you will have the 2 pi, 2 product pi, then you have the same curve. So if you are choosing here 0 to 2 pi, and you can see the length of the x value we have is 31,416. Okay, it is very large. But if you decrease the value, we have the same result. Okay, so sometimes we need to think the value of dx or the increment depends upon the length of the interval. According to that, you should choose the value so that complexity can be reduced. Similarly, here is one more example. Okay, if you write your own function like user-friendly function, okay, user-defined function, then you can call the same function as we discussed yesterday at this place. Okay, as you have my function, then just you need to replace a sign function by using my function. Okay, so in this way you can use user defined function also to create this type of function by using for loop and to compute the values. There are many type of functions like a series function, and we need to write a function to define them and to study the behavior of the series or series function. Like all the Bessel function can be, or hypergeometry functions we have in the form of a series, and all these functions we can write by using for loop. Here we have one example. This is one more example for the same, but in a different way. What we have in the second example, we are using, the difference is only that we are using here line space. Okay, in the previous we have 0 to 2 pi, but here we have line space, and by using this will generate 100 point, and rest all the things are same. See, this is one more example. Here we have a series like 1 plus 1 by 2 plus 1 by 3 and so on plus 1 by n. Okay, we want to calculate the sum of this series. Okay, so how you can simplify, or how you can calculate the sum of this type of series by using for loop? It is very quite simple. If the series include only one argument, then here is n only. Okay, and sometimes we have a series of function of series. That also can be, we can extend by using the same process. But here we choose here a very simple series, and how we can compute. So first we are writing at this place function, and use at this place this bracket also, and is equal to compute. I give the name of the function compute series sum. Okay, and n is the argument which we want to pass. So while you are using for loop, you need to initialization value. Okay, so first value you have to assign. If you want to include this value in the for loop, then you have to take 0. Okay, if you are choosing this value at this place, okay, then you have to start this loop from 0. Okay, so note this point very carefully. Here, what we are doing, this is the first index. Okay, so we will take the initial value which is 0. This is the initial value. To initialize, we need one value, and we are choosing here 0. This 0 will pass at this place. So first see the array. This array will start from I is equal to 1 to n, and n is natural number because this is series in this form, and n is a natural number. So just we need to enter only the value of n. Okay. So the thing is, for I equal to 1, 2, 3, 4, if at this place we have 5, okay, then the loop will work from 1 to 5. This value will pass, this is the first value, and the first value we are choosing 0. Okay, when I is equal to 1, then we have 1 upon 1, which is 1, and 1 plus 0, 1. So for I equal to 1, this will calculate the value which will be 1. When we have the I is equal to 2, okay, so the value which was computed at this place stored in at this place. Now the updated value will return to this place. Okay, 1 will be entered at this place. Then for I equal to 2 means 1 by 2. This value will be simplified, means sum of these two terms. Now the first term was 1 and second term is 1 by 2, because I is equal to, when we have 2, it becomes 1 by 2. So this will be the sum of first two terms, 1 plus 1 by 2, and this sum will be updated and stored at this place. So when it will choose the next value, I is equal to 3, this updated value will be returned at this place. Okay, so the sum of these two terms is at this place, and when we have I is equal to 3, this is 1 upon 3. So the sum of these three terms will be computed at this place, and this value will be stored on the left hand side and will be updated. So in this way, this for loop will work until the last value of n. Okay, so this is the for loop. By using, we write a function to compute the sum of the series, and now we want to use this series to find out the sum. Okay, here you can find.
Hello, sir.
Yes, sir.
Yes, I noticed that in that program, there n is not yet defined. So how will it run successfully?
Pardon?
If you flash back to that program, you will notice that n is not defined. The value of n is not specified. So how
Okay.
will it run? Yes.
Yes, yes. See, so first, just we are writing at a place a program. Now
Okay.
we will enter the values in the new file. To get
Okay.
the values, whether it is correct or not, we will do now experiment. First,
Okay.
just we need to write a function. Then after we will do experiment on it, whether it is correct or not. Okay.
Okay, sir.
So now this is the program for all these terms, whether it is 100 term or 1000 term or more than 1000 terms. This will work for all type of values. But the series is starting from, you can see 1 plus 1 by 2 plus 1 by 3 and so on. This is the first term, this is the second term, this is the third term, this is the nth term. Okay, the value of n depends upon our choice. And what is n? N is natural number. Okay, see, now we have this function. This is the function C at the place, and come here. Okay, now we are do some experiment. At this place, we are passing the value of 5. It means this will be 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. And this will return the value, this which is 2.28. If you want to check the sum for 1, it means there will be only one term, and sum of one term we have is 1. Check it. Sorry, for 1 it is not returning, not enough argument. Sorry, we have to run from this place. Yes, check it. It is 1. We cannot run from this place because this is the function and we have to pass the value, and to pass the value you have to run this part. You need to call this function at this place. Okay, so, and when you will choose the sum of 2, it means 1 plus 1 by 2, and 1 plus 1 by 2, the value is 1.5, which is correct. If you are choosing 3, it means 1 plus 1 by 2 plus 1 by 3, and you can check it. Okay, if you before using this type of function anywhere, first you need to check the known values, the program which you write, whether it is correct or not. And after for the known values, if it is verified, then you can use for any value. Okay, so here you can see we check all these values. For 1 we have 1 value, and if you are choosing 2, it means 1 plus 1 by 2 must be 1.5, and we have the correct value. If you are choosing at this place 3, then you need to check, you need to calculate the values 1 plus 1 by 2 plus 1 by 3. This will be 1.83. Okay, and you can use at this place format long format. Okay, yes, so this is the value. Now you can do numerous experiment. I am choosing here for 10 sum of 10 term. We have this value. You can increase the number of zeros we have. 100 term, we have the sum. You can choose some of these term, okay, and you can run. So the sum of the corresponding to these terms, we have this value. You can increase one more zero, 20, and you can get the sum. We have the sum of corresponding to these terms. Okay, some of these terms has been calculated just by writing a simple program. Okay, so the same thing can be extended for numerous functions like Bessel function we have in the form of a series, and all type of hypergeometric functions. Okay, all the functions we can extend in the form of a series, and by using this for loop you can write your own function, okay, to compute the values. I will upload some lecture or the script file for Bessel function, for hypergeometry function, for Mithazel function. 2 or 3 example will be shared with you in the coming session, so that you can understand how you can write a function which is in the form of a series or by extending in the series. Okay, all type of function can be extend in series form, and then you can write all type of functions to compute their value, to study their behavior, visualization, and numerical values for every task what you need. So this is the use of for loop to write a function to calculate a series. And here is also, I think, one more example, user defined function. Yes, in this folder there is, yeah, here is factorial function. This is very interesting example which I prepared at his place, and all these file I already shared with you. And this is very beautiful code here, and will help you in many programs. Okay, so here we want to write a factorial function. So the thing is, in the case of factorial, we cannot enter negative value. We cannot enter any fractional value. Okay, so all the values must be positive integer. So all these type of conditions first we need to apply. Okay, and the value must be numeric. Okay, so here what we are doing, before applying the loop, we need to check the values. If we are entering incorrect value, this will return a message, error message. See here how we can check all this and how you can write a very smart program. So here the thing is, we define at its place a function which is factorial function, and by using the same we want to calculate factorial for positive integer using for loop. So first we need to check the value which we are entering. Okay, whether the value which we are entering is correct or not. For that we have to apply the condition. So this is the control statement. Okay, this is the control statement which will manage or control the workflow of the program. See here, uh, this is the sign of negation, is numeric. This will predict whether the value entering value is numeric or not. Okay, if you are using this function, if you are using the function at its place, and here is the value is 5. Okay, and when you will enter, so this will return the logical answer which is 1. Okay, it means this is true. This is true. The value which we enter at this place is numeric. Okay, if you are again trying to enter, here is, suppose it is a, and you know a is not numerical value, and when you will enter, or any string, sometimes we have any string, sorry, you can enter here any string. You can see here, this is 0. Okay, means this value is not a numerical value. So this is numerical function will it predict whether it is a numerical value or not a numerical value. So the thing is, the value which you are entering here must be numerical. So we are applying here, if the value will not be numerical, then this message will declare. And if the value is, this is the sign of or, n is less than 0, if the value is negative, then this message will be printed. And if mod n1 not equal to 0, this will check whether the value is integer or not. Okay, we need positive integer. What do you mean by mod n? Mod n comma 1. You know about this function? What is mod n1? Okay, let's say we do some experiment. CLC. If you are using mod 5 comma 2. Okay. So this is remainder. What is 1? 1 is remainder. Okay. If you are using here 3, this is remainder. Okay. If you have this number, if you have CLC, if you have this number, add this place 1. Okay. It means remainder will be 0. Okay. So by using this one, whether the number is 5 or 6 or 10, in all these cases, sometimes you can enter -5. Okay. So this will not be equal to, or sometime the value which you are entering here, like 1.5, then remainder will not be equal to 0. So that also be the not the integer. Okay. So first we need to verify all the values whether it is a positive integer or not. See here, if you are entering here 1.5, 1.5, and we know 1.5 is not an integer. Okay. And this will return remainder is 0.5. Okay. So if the remainder is not equal to 0, then this is also an error. Okay. So in the very first statement, we will check all the things. Number one, the value must not be, if is the value which we are entering, whether it is a less than 0 or whether its mode is not equal to 0 or it is a string. In these three cases, this message will appear and the code will not work. Okay, this will return this error. And then after, if the condition is satisfied, if this condition is satisfied, the value which you are entering is positive integer, then the next statement will execute. Okay, so for the factorial, first value will be 1. Okay, then you will write for loop at this place. I is equal to 1 to n. And the value of n depends upon our choice, whether it is a 5 factorial or 6 factorial or 10 factorial. Okay, so what this will do, we will just write as we do for the summation. In the same way, we will use at its place for loop. But the thing is, we have to use product sign at its place. Okay, so this value will be used at its place, and for I equal to 1, this is 1, and 1 into 1, it will be 1. Okay, now we cannot use at this place 0. If you will choose 0, then this will become 0, and in each case it will return 0. So that's why we are choosing at the place 1. Okay, So this is 1, then 1 into 1, this value will be stored in the left hand side. Then it will choose I equal to 2, and 1 into 2, okay, at this place the value will be 2, and the value will be stored at this place. Now this value is 2, okay. Then this I will choose the next value, which is 3. So 2 product 3, 6, this value will be updated at this place, and the loop will work until the last value. So this is the program for the factorial. Okay. Now we can check at this place. You can start. We call at this place the same function which we create for the factorial. Okay. Just you need to copy and paste. Now you need to pass the values. If you are passing the value 1, and 1 factorial will be equal to 1. If you are passing the value 0, 0 factorial is also equal to 1. If you have 5, then you can see this is 1 to 5. If you are passing 1.5, what must be the answer? 1.5. See the message. Input must be a non-negative integer. We defined this value. This message appeared because the value which we pass at this place is 1.5. Okay, 1.5 satisfying this condition. Okay, the value not equal to 0. That's why we have this error message in the program, which you get the message at this place. If you are entering at this place -1, I am passing the value -1. See what happened? We have the same message. You can check it. Okay. Now the value of -1 is less than 0. This condition is satisfied. That's why we have this error message. Okay. If you are passing at this place any string, this is, we have now a string. Okay. And you will get the same message. We have the same message. Okay. So all these conditions while writing the program, we have to define. Okay. We define at this place when all these are justified, only then this loop will work. Okay, so this is the workflow of any program which you need to understand the logical statement, all type of loops. Okay, logical statement are there, logic operations are there, and conditional statement are there. Okay, so you need to understand also the conditional statements. So these are the conditions, and on the basis of these condition, we are controlling the entire program. And here, along with the conditional statement, we are using loop. This is the loop. For loop is started from this place and end at this place. Okay, and this end is used for our function. The function starting from this place and end this place. So these small programs will help you to understand, to write the different type of program. And once the concept will be clear, then you can extend for different type of programs which you need for your different type of problems and the experiments which you need for your work. Okay. Here is one more example. This part has been discussed. Okay. For loop, then we have while loop. Yes, this is while loop. So here we write Newton-Raphson method. I think all of you are very familiar with the Newton-Raphson method. Okay. Yes, you can see this image. If I need to increase the size, we can do how I can increase the font size. Okay. Yes, yes, yes. Are you getting this image? So we have fx is equal to x square minus 4, and using the Newton-Raphson method, the formula for the iteration is given by, this is the formula. Xn plus 1 is equal to xn minus fxn upon f dash xn. Okay. So we write the program for this in Newton-Raphson method, and then we will compute, or we want to we will find the root of the above equation by using Newton-Raphson method. And I hope all of you are very familiar with this method. So how you can write the program? See here, very simple. So first we write the program function will start from by using function, and this is the output value, and output value is root of the equation. Okay. And first when you are using Newton-Raphson method, first you need to initialize, or you need to choose one value. Okay. In it, by choice, by default you can choose any value. This is the initial guess, and then tolerance depends upon your choice. Okay. So these input arguments are required, and we have this function which we need to guess. Okay. So first we need to initialize guess value or any value. Here we will apply while loop. We are using here while loop. So the absolute value of x square minus 4 must be greater than tolerance which you will choose at this place. So when the value is this value is greater than tolerance value which you will assign or you will fix, only then this loop will work. Okay. And when this value becomes small, it will stop, or will be equal, will stop automatically. So this is the formula. This is the formula, which is xn is the left part is xn plus 1. This is xn. Okay. This is fxn. We have fx upon f dash x. Okay. So its derivative will be 2x. So this is the function with which we can easily write by using the Newton-Raphson formula. Okay. This is important only. Then after the output value we have is root, and root is this value x, and we enter the program. Now we want to get the solution. Okay. So the thing is, you can now call this function to find out the root of this equation. So we are using this function. Okay. You can initialize by using any value. First, I am choosing at this place the initial guess is 3, and tolerance value I am choosing at this place 0.01. Okay, 0.01. You can make more small, depends upon your choice. Okay, so a small as you choose, we have more accurate answer. So first we are going to start from this value. Now the function which we write at this place is now used at this place, and both the we have to assign the initial guess and the tolerance value. Both will be passed through the function, and this statement will display the result. As you know, display is used to display the result. As we discussed in the yesterday, how you can use this function. Okay, this value will be printed at a place, and this value, which is numeric value, need to convert into the string, because this part is string. So this value must be string, only then this will print in the command window. Otherwise, this will not print the value. When you will run and you see that the result is 2. If you will choose 3, or if you are choosing 5, so the nearest solution for the above equation we have is 2. Okay, you can choose any value. If you take 0, then none, no solution, because when you have x equal to 0, and you know that this value become -4. Okay, none means, what do you mean by none? None means not a number. Okay, so you can choose at the place 0.1. Now we have 2. If you are choosing here, the initial value is -5. Now you have, the solution is -2. Okay, so for this equation, x square -4, you have two solution. One is 2 and other is -2. Okay, so by using this program, you can easily find out the solution of this equation. And in the same way, there are so many numerical methods, and you can extend to find out the solutions of any type of equation by writing the program. And while loop you can use for the same. Okay, so this is the proper use of while loop and for loop. Any doubt between these two examples, how we can use for loop, and how you can use while loop to write the program? Is it clear? Any question, please? Any question, please?
You can continue, sir.
Okay, thank you. I don't know why you are not asking any question. Okay, so now the most important thing is conditional statements. These are also very interesting and useful. So here is a very simple example, and two examples are there I prepared for you. And first you need to understand what do you mean by conditional statement, and all these files I have already uploaded and I shared in the group. Okay. So the sometimes when we are writing and our function depends upon some conditions, and if the condition is justified, only then that particular statement must be executed. And this type of these condition statement help us to write the function. For example, if you have the function in mathematics like piecewise continuous function. Okay, so to write the piecewise continuous function, you need a conditional statement, because the piecewise continuous function depends upon the conditions 0 to 1 interval, then 1 to 2 interval, 2 to 3 interval. Okay, and corresponding to these intervals, we have the function value. Okay, so this type of conditional statement will help you. First, we have if statement. If I ask what do you mean by the conditional statement? Conditional statements in MATLAB allow you to control the flow of your program based on certain conditions. MATLAB support the standard conditions statement found in most programming languages like if else, and else if functions. And all these are some examples for their format. Okay, so if then at this place you will put condition, and at this place on the basis of condition this statement will execute. At this place this will be the part of statement, and then you will end. So this is the one part, if and statement. Okay, if you are using if else, if you have only one condition, then you will use only if and statement. If there are two conditions, then you will use if else. Okay, so if, then at the place you will have the first condition. Okay, then and at its place on the basis of this condition you will have the second statement at its place, which is justified according to this statement, this condition, and this statement will be executed if this condition is justified. Otherwise, what will be the second condition or the second statement will be executed, which we have at this place. And if you have the conditions 2 or 3 or 3 statement, like if we have the first condition, then we have the second condition, and then we have the third condition. Okay, so if else if statement will be used, and I will give you one example for each how you can use all these statements. Okay, so first condition will be used at this place if the condition is justified, and the code which you will write at this place will execute. Then if this condition is fail, the program will check the next statement. Okay, if the condition is available at this place, this condition will be checked, and on the basis if this condition is justified or verified, the statement corresponding to the above condition will be executed at this place, which we will write to the program. If this condition is fail and this condition is fail, then whatever the statement you have, which you will write at this place, that statement will be executed. Okay, so here we will discuss one or two example. You can check here. Yes, this is the first example. In this example, you have this is the first condition, this is the second condition, and if this condition not satisfied, this condition is not satisfied, this will automatically verified or will print the value. See, so there are logical operators. You can check here. One double equal two. Now in the MATLAB, double equal means logical operator one is equal to two, and when you will enter, logically this is not true. Here is zero. It means logically this statement is not true. Similarly, one is greater than two, and when you will enter, logically it is again false. Okay, and two is less than three, and when you will enter, it is one. Okay, so less than and greater than, all these are logical operators, and negation. This sign is of negation. Okay, negation of 0 is equal to 1. Okay, negation of 1 is equal to 0. So all these are logical operators, and these are also very helpful to write the program and to check whether it is justified or not, because all the conditions will be checked by using these operators. See here. So this is the first condition. If x is greater than 0 and the value of x is greater than 0, it means this is positive. So this is the statement. Display x is positive. Okay. Else if x is equal to 0, will display the value is 0. Else, now the value which is not greater than 0, the value which is not equal to 0, it means this will be less than 0. Third part is the value of x is less than 0. So here for the two conditions we are using if, then we are using else if, and for the other condition whatever we have we will use else function. Okay, along with else there is no condition and it will return negative. Now you can check all these statement and how according to these conditions this program will execute. Okay, we are using here CLC colon clear. Now execute the function. You can see the value of x is equal to is we have is -1. So this condition is not satisfied. This is also not satisfied. So this value will print at its place x is negative. If you are using at its place 0, okay, so this statement will automatically execute because x is equal to 0 and this condition is satisfied, this value will return. See, execute the program, x is 0. If you are choosing at the place 5, 5 is greater than 0, this statement will return. You can check it. So in this way, you can control the program flow by using these logical operators. And here is also one more example. Here is one more example. Sometimes come back here. Yes. The last part, logical operators. Okay. So this double AND means and vertical lines means or, and this means not. Okay. Yes. So here we have A is equal to 5, B is equal to 10, and sometimes one condition depends upon uh, uh, if you have we have two conditions and both the conditions we want to apply together. In that case, we have to use AND function. Here A is greater than 0 and B is greater than 0. Okay. So you can see display both A and B are positive. Okay, if you make one value negative, then no answer. Okay, because both the conditions must be satisfied, only then this will execute. If you are using here is or, if you are using here is or, so at least one condition must be satisfied. Okay, then this will return. Check it. Now we have A is equal to -5, B is equal to 10. Okay, either if A is greater than 0 or B greater than 0, we one condition is satisfied. When you are using or, then one condition must be satisfied and this statement will be execute. You can see if this is also negative, then this logic is true or false. Check it. False. Okay, so the program was we have Control Z. So in this way, you can use this program for different type of operations. Okay, and based on, I think there is one more function at this place by using these logical operators. You can check, and all these files I have sent on your WhatsApp group. Just you need to check all these values. Absolute function. Okay. Yes. check here. So by using these control statement, we write at this place absolute function. Okay, so this is the only the functional statement, and we write here user defined function to compute the absolute value of x, and which is very quite simple. If x is greater than and equal to 0, if x is greater than and equal to 0, result must be equal to x. Okay, else result must be equal to minus x, and this and used for this one, and this and is used for the function. Okay, so this is a very small function for absolute or modus function, and you can execute here. Yes, you can check for 5 and minus 5. Okay, this is the first value. We are passing here 5, and at this place we are passing minus 3. And when you will execute this statement, yes, you can see if you are passing the value 5, the return value is 5, and if you are passing the value minus 3, that is also 3 because of the absolute function. Okay, and also there is one more example, but you can check yourself, and is very quite simple. Here is user defined function for my math and numeric math. Okay, so here we are getting the square root, and some conditions are there. If x is less than 0, if x is less than 0, then we have x square. Okay, then we have x square. So this is function which is like fx is equal to okay, and then you can take here. Okay, so this is when we have x is 0, then we have x square, then we have x square for x is less than 0. Okay, then we have again, if we have 2x, we have 2x for x lies between 0 to 5, 0 less than x and less than 5. Okay, and then again we have square root. Okay, sqrt is a square root function in MATLAB. Okay, for x is greater than and equal to 5. Okay, so this is now we have one of the simplest piecewise continuous function, and for that we want to write a function. So first we will apply this condition. If x is less than 0, what should be? Function must be equal to x square. When we have the value of x lies between here is less than and equal to 0, less than and equal to x, less than and equal to 5. Okay, this is the second condition. Now we will apply the second condition, and if this condition is satisfied and or corresponding to this condition, we have function is equal to 2x. Here is 2x. Otherwise, because these two conditions are satisfied and corresponding to this, we have the two functions, and this is the last one. Okay, then we will use at this place else. and will be equal to SQRT. So this is the function and one example to write piecewise continuous function. Okay, and you can define a function. Then after writing the code, this end is used for the if statement. Okay, and this end is used for the function. Okay, now the code is complete. Now you can run the code corresponding to all these. So here we are CLC and clear, all these are very familiar. We are passing different values. First, we are choosing -2, then we are choosing 3, then we are choosing 9. Okay, and when you will execute and check all these, you have 3 answers. Okay, so when you will have -2, -2 will pass. When you have the -2 means x is less than 2. This statement will be executed. Okay. And -2 square will be equal to 4. You have this answer. If you have the next statement 3, okay, and 3 lies in this interval. This condition is satisfied. And 3 into 2 we have is 6. Then else, okay, when we have the value which is greater than 5, 9 is greater than 5. Okay, for the other values, the last statement will be automatically executed. So in this way, you can use this control statement. Okay, for loops are there. So all these conditional statement, logical operator, and loops. All these help us to write the program for different type of prompts to give the instruction to instruct the MATLAB to manipulate the statement according to our desired value. And for that, we have to use control statement. So in this way, all these control statement will surely help you in many ways for all type of to write mathematical model, to write numerical methods, their programs, their visualization after writing the program to check the values according to the condition. Okay, so these are basic operators which are desired to understand, to apply them, and a lot of experiments need from your side also. Okay, only to present or listen from me side, not sufficient. When you will do some experiment, you will choose your own example, you think according to your problem. Okay, choose your own problem and start from the very simple examples. Choose, try to write the program and check where is the problem. When you will write yourself any simple program, you will face the problems and find the error why your program is not running. Okay, if program is running, then fine. If not working, then check the error. Okay, then you will be master to use this statement and you will be very familiar how you can use for different tasks. Okay, any question related to all this? If you have any question, if you have any question related to this content which we discuss, otherwise we are going to start now symbolic mathematics. Is it okay? Is it okay?
Yes,
Jasprit
sir.
ma'am, Jasprit ma'am, are you getting? Thakur Sahab,
Yes, sir. Yes,
or
sir.
Kavita, are you getting all these things which I present here? Is there any question? Please feel free to ask from me so that I can more elaborate all
बच्चे
this.
कहते हैं छोड़ के अब इन्होंने 3 घंटा पढ़ना है तो इन्होंने क्या किया कि
Pardon? Snower, you are asking something?
No, sir.
Okay.
Hmm.
I am very surprised to see that there is no question from your side.
Hello, sir.
Hello,
Yes, sir.
how, how are you?
I fine, sir.
Great.
Actually, you tried very well because your class is self-explanatory. But I was thinking that you could also highlight some conditions where some of those controls flows can be applied. Okay, like okay, when am I if I'm running a scientific computing program, when I'm on under what condition, under what scenarios should I be able to use the while loop? Or under what scenario should I be able to use the for loop? You understand? Or the if else whatsoever conditions. So I think if those conditions are clearly specified, um, it will make it very easier for us to also apply them.
Thank you. So the main thing is the content which we are presenting, which we are discussing. You are spending a lot of time, valuable time, okay, and you are listening very carefully.
Yes, sir.
Yeah. So the time which you are spending must be very productive. And
Yes.
all the content which we are trying to present here, I am sharing with you so that you can do some experiment on it. You can use for future also. And all the content which we are presenting here, the recordings are available on your account if you are registered on this platform, or otherwise we are uploading on the YouTube also, so that after uploading there, we are providing the link. So each type of help we can share with you. And I know okay, after using all these content will help you in many ways to learn MATLAB for your purpose, for your work, okay, for your future use. So I'm very thankful to all of you. You are listening very carefully, and don't hesitate if you have any question. Uh, Now we are going to discuss about the symbolic mathematics. Okay. So if I ask what do you mean by symbolic mathematics from your side, can you give any some example? What do you mean by symbolic mathematics, and why symbolic mathematics is important? Yes, anyone? What do you mean by symbolic mathematics? Mr. Jayaprakash ji, can you please explain symbolic mathematics? Thakur Sahab, Jaspreet ma'am, Gangtak, Nanpon. Okay, no problem. Not issue. So I am sharing my screen with you. Okay, this is my screen, and these are the files. Lecture 1, lecture 2, lecture 3, 4, 5, 6, 7. Okay, so see, and all these are very simple. You can use all these content yourself, and I just let you know how you will use. And the concept are very clearly I try to explain in all these presentations. So in the very first symbolic math toolbox, create symbolic number, variable, expressions, create symbolic variable, create symbolic expression, reuse, and create symbolic functions. All these are very quite simple. So first, the thing is, what do you mean by symbolic mathematics? These are some key features of the symbolic mathematics. You will go through this theoretical part. I would like to skip this one. This is important for us. Okay, along with I will open my MATLAB. So if you will write here 1/3, we have this value. Okay, if you are choosing this value, sim is and 1/3. It run the same value. So what is the difference between the previous statement and the second statement? If you have pi, we have this value, and sim pi. It is returning the same value. So from these two statements, what you understand?
Okay, from the first one,
Mhm.
the first one and the division operator has acted on 1 and 3. But in this one, the division operator, okay, on the first one, the division operator acted on it and the result has been displayed. Then in this second one, which is the same 1/3, the result is returned as though processed, but is returned as imputed.
Okay.
Yes, sir.
Let's anyone format bank 1/3 and sim 1/3. Okay. Do you think this value and this value both are equal? Is 1/3 is equal to 0.33?
They are not exactly equal, sir.
1/3 not equal to 0.33 because 0.33 is only the approximate value, not the exact value,
Yes.
right? Okay,
Yes,
if
sir.
you will change the, if you, because 0.33 in the previous we have a 0.33333 and so on. Okay, if you will change the format long and then check 1/3. Okay, it means there will be more threes after these values and will continue. Okay, so this is the exact value. When you are using symbolic or you want to convert in the symbolic, it means that will be the exact value. Okay, and this is the approximate value. While we have the computing, and if we are only using the two places value, two decimal places value. Okay, so but this is the not the exact value. When we have the long program and again when we are using this approximate value, ultimately our final result will be affected by using this value. So that's why we need the symbolic value, which will be the exact value. Okay, this will return our findings more accurate. One thing. Number two, along with we need some symbolic variables. Okay, and symbolic variable, with the help of defining symbolic variables, we can simplify different type of differential equations, different type of functions. We can manipulate them according to our choice. Okay, so here we have the some example, and then after similarly we have the for the SymPy. Okay, if you are using SymPy in this way or in this way, these both will return some difference. This part you can directly use in the MATLAB. Okay, these are the syntax which will be in the MATLAB. These are text and these are MATLAB code. Okay, specific syntax are there. You can directly use in the MATLAB. Yes, this is 0. Okay, and if you are using SymPy, okay, so this is the exact value of pi. That's why 0. But here pi means 3 point. The value of pi is 3 point this value. Okay, which is not exact value. You know, this value is not the exact. This is approximate value. That's why we have this answer. You must verify all this and will help you to for more understanding. So now the thing is, you can easily create variables using either sims or sim. You can use sims function or you can use sim function to define a function for different type of computing. Like if you want to simplify some type of differential equations or a system of differential equations, or you have the matrices in the form of a symbolic, and you have any kind of mathematical model or integration problems, you need to define symbolic variable. There are two different ways. You can use a sim function, create a numbered symbolic variable, or create symbolic variable in the MATLAB. And sims is used to create fresh symbol variable for interactive symbolic workflow. That is for the symbolic variable at the MATLAB command or in the MATLAB live script. Fresh symbolic variable does not have any assumption. Okay, so this will return us a fresh symbolic variable, and this once you will define, you can use. So either you can use this part or this part, but when you will write the program, you will understand the difference between these two, how you can use all these. Okay. So here are the examples. Sims AB. See here, CLC. Okay. I am writing here sin X. I write here sin X. There is an error. Okay. If I use in this way, Sims X, Y, Z, enter sin X. Now there is no error, because here we define here at the place symbolic variable. That's why there is no error. If you are writing in the direct way, then MATLAB not recognizing the value. What is X? Okay, so define any function, you can write, you can define them, and then after you can use. Like if I have is f x y, x comma y, okay, is equal to you can write x, you can write here sin x plus y, and then enter. Okay, now f, and you can pass the value 0 and pi, because the function is defined at the place. Now you can manipulate this function in any way after defining the symbolic variable. So you can define in this way also, like y is equal to sim by using sim function, and here is cosine y, and again then enter. Okay, so this is also the symbolic variable, and now you can use Now you can use anywhere. See. Okay, so in this way, you can easily define the symbolic variable. If you want to define in the group, then you will use this statement. And sometimes you need one variable, you can use also this way. Okay. Now here you can see clear all, and sometimes you need a multiple of symbolic variables. You can generate by using this statement. A is equal to same, and here is A in quote sign, and these are the index 1 to 20. So when you will execute this statement in the command window, this is the output value. Okay, you can see A1, A2, A3, A4, and so on, A20. So 1 to 20 index symbolic variable has been generated. You can check in the MATLAB also by using this statement in the MATLAB. You can enter here CLC, and here is quote sign. Here is quote sign. Correct it. When you will copy from the PDF file, then you must check the sign. Okay. You can see all these are symbolic variable. Okay. Now you can use A1. No error. Okay. A is equal to, yes. So all these are stored in this one. And these are the element of this matrix. Okay. This array has these symbolic variables in the form of. Now you can use, you know about the whose statement we already used in the previous, in the beginning. And here is also one more statement is given, you can use in this way. CLC and sims, sim of, yes. Okay, you can use and check this. What this will return for you. Make it correct. Make it correct. Then and enter. Yes. So we have a multiple statement. This is also, we have, these are the all the variables which was generated at this place. And this is these are index A1, A2 up to A10 in the first column. And you know, here we are using whose statement. So whose statement will return some more information about the variables which we generate at this place. Size of each is 1 and bytes are 8, and all these are symbolic, and class attributes are missing. Okay, so you either you can use this statement also. Sometimes these are required while computing different type of problems, but you must be very familiar about all this, how you can generate in group. So what create a symbolic variable and what are the use and why it is required? Okay, the sims command is convenient to shorthand of the sim syntax, and its typical use is to create fresh symbolic variable for interactive symbolic workflow. Okay, and symbolic variables in the MATLAB we can use for many numbered symbolic variables. So we can use the same function, a symbolic variable whose values differ from its name in the MATLAB workspace. Okay, you can use symbolic number such as, if you need to define symbolic number, then you will use this statement sim5. Now sim5 is symbolic number. Sometimes we need to convert in symbolic number. Okay, then you will use for n number in this way. And a symbolic variable that inherits assumption from previously used symbolic variable having the same name. Okay, so now here is very interesting example by using the symbolic variable. This is golden ratio. Phi is equal to 1 plus root 5 upon 2. So here we will define this function in the form of a symbolic. Okay, if you are not using this symbolic function, because here is root 5, here is root 5. Okay, if you are not using symbolic, then the thing is the value of square root 5 will be calculated. Okay, if you are using square root 5, see, if you are using square root 5 at its place, this will return in this way. Yes. Okay, this will return in this way. Here is one error, one bracket was missing. That's why we have one error. Okay, so when you are using the statement in this way, it means square root of 5. And if you are using only SQRT, if you are using in this way, so this will compute the value, and which is not the exact value. That's why we are using here symbolic variable. Okay, and now we have this polynomial f is equal to 5 square minus 5 minus 1, and we want to pass this value will be passed through this function. This value, the value of 5 is this value, and this value will be passed through this polynomial and will return this value. You can check in the MATLAB also. You can check in the MATLAB. Okay, then the second statement is this polynomial. You need to correct this statement. Here is cape. Now it is correct. And this value of 5 pass through this one, and all the values are returned in the form of symbolic. Okay, all the values here you can find in the symbolic form. Similarly, you can write quadratic equation, and you know this quadratic equation involve a, b, c parameters, x is variable. Then you need to define first all these the parameters and variables. Okay, since it will help you to generate or to define all type of parameter, variables or integers which you need, you can do in a very easy way. Okay, so here you can see f is equal to, you can write the program. First you need to define all these. I am copying directly because to save the time. So A, B, C and X. Okay. Then after we have this polynomial. But here we have is cape sign for exponent. Okay. Now you can enter. Again, it is saying that also you can there is a solve function. We try if it will work for this one. Solve f. Okay. Yes. So we have this polynomial, and when you will use solve function, okay, it is returning the solution of this polynomial in symbolic form. The answer is in symbolic form. If you are not defining this symbolic variable, then you are not able to find out. First thing, you are not able to write the any polynomial, and you are not able to solve the polynomial in a symbolic form. So when you will define the variables and parameters, and you want to compute all these calculations in a symbolic, and you can do easily. You can see at this place. Okay, so this is the use of symbolic function, and how you can define and how you can use. So all these operations you can do very easy. Here you can see f is equal to sims a and b. F is equal to, we have a plus b. You can do this operation symbolically. Okay. So these are some examples which are presented here. And here is also one. Sometimes you need to define a function in symbolic form, and you can do here. This is the symbolic function. Okay, fxy. Now you, by using the same function, you can write your own function. See, at the place fxy is equal to x square product y. And when you will enter, this value will return. Okay, now you can pass this value. If you want to calculate the value of the above function 832, what you will do, just you need to pass the value, and this automatically simplify the value of this function 832. Okay, so this is the easiest way to define the symbolic variable, as well as the function involving several variable, and after that you can manipulate according to your prompts. This is one slide, and I now just explain the things which are available in these presentations. Okay, so here in this slide we will cover derivative, integrate, solve equation, simplify. Many things are there. This is the same example. You can see now. Yes, here you can see the x variable is equal to 1 to 5, and y variable 3 to 7. These are two arrays, and these two arrays having same length. The thing is, when you are passing the arrays, you are passing the values to into the function of two variable in the form of array, the length must be equal. Okay, so the length of this one and the length of this one, both are equal. Now you can pass this array to the function of two variable fxy. So this array will pass at this place, and this is the second array. And corresponding to this array, we have the values. If you want to check, you can do. First, we are defining this function. You can use in the MATLAB. Go to define. Then you will choose this function. Okay. This is the second statement, and correct this sign. Use the semicolon, and now. Then after we have these two arrays, x array and y array, and we want to pass these two arrays through the function and enter. You have the corresponding answer. You can check it. Okay, so all these part are the syntax of the MATLAB. You can use directly in MATLAB. Also, you can see here dfx. This is the only assignment variable. Diff is inbuilt function in the MATLAB for derivative or for partial derivative. Okay, now the function f which you defined at the place is involving two variables x and y. Here we are using diff function to differentiate f with respect to x. Okay, and when you will enter this one, when you will enter this statement, okay, see what happened. This is the partial derivative of this function. Okay, this is partial derivative of this function which we defined at the place. This is f xy is equal to x square y, and only the diff function will return the partial derivative of the above function. If you want to differentiate with respect to y, you can change the left hand side, and here is y. Okay, we need only this part. This will do the partial derivative of the above function with respect to y. This is only the assignment variable. Yes, it is x square. So in the same way, if you want to pass the value, you want to calculate df xy 8, x is equal to y plus 1, you can do. Okay, just you will put the value y plus 1 at the place of x, and this will simplify automatically. So many type of operations, computing part you can do by defining the symbolic variable. This is one of the, if you want to write matrix in the form of symbolic. So first you need to define symbolic parameters, and then you can use, and when you will enter, this is the matrix of 3 by 3 order in this form. Okay. Yes, this is also interesting thing we have to use. Okay, what do you mean by this element? You know about the matrix operations? Okay, we must check all this so that this will help you, because matrix topic we did not cover, but here we need to discuss. So we have this matrix, okay? First row we have ABC, second row we have CAB, third row we have BCA. When you are using only this part, C, we are using A means matrix 1, comma, colon, and when you will enter, this will extract all the element of first row, and first row is ABC. If you are entering like 2, A2, comma, colon. Colon means all the element of the row. So this will return all the element of the second row. Okay, so this will extract or access the second row. If you want to access any column, then what you will do? I want to access first column. Okay, I will use in this way. So this will access the all element of first column, A, C, B, and you can check all these element in the matrix. First column is A, C, B. Okay. Similarly, you can use the same to access third column. Okay. So the thing is now, the meaning of this one is all the elements of first row. Okay. And sum means sum of the element in the first row. But here, yes, so these are the corresponding values. Okay. A plus B plus C. If you will change, it is 2. This will be also same because the element in each row and each column are same. CLC. Here is some logical statement. Is always sum A 1 comma colon means sum of row element, first row element, and sum of second column element are equal. So when you will enter, this is logical statement. Okay. So logical statement is used at the place, and when you will enter this statement in the MATLAB, this is the input statement. This is the input statement. Okay. And it is 1. It is 1 means true. You can see. Similarly, we can generate the matrix like in this way. If you need to generate the matrix, you can use sim24, and this will return the matrix in this form. So you can, this is the another way to generate a matrix in the symbolic form by using A percentage D when you will enter in this way, and 2, 4 is the order of the matrix. This will return the matrix element in this way in symbolic form. This is the Hilbert matrix, okay, which is inbuilt matrix in the MATLAB. By using this statement, this will generate the matrix of 3 by 3 order, which is Hilbert matrix. You can convert by applying symbolic function in the symbolic form. So the above Hilbert matrix, when you will use sim A, this will convert the matrix in the symbolic form, which is Hilbert matrix of a 3 by 3 order. Okay. So this is the another form of the above matrix. So here are the some few examples for the same to differentiate, to integrate all which are required for scientific computing. So here is the very simple example, sim x, and we are taking here a function of one variable, which is sine x square, and either you will use diff f or you can use diff f comma x, because here only we have x variable, and by default, when you are using in this way, this will automatically choose the x variable. Okay, if the function is involving more than one variable, in that case, you need to define whether you want to differentiate with respect to x or with respect to y or z. Okay, so you can use one of these statement, and this will return the derivative of the above function. Sometimes you need higher order. So for higher order, you can use this statement, diff f comma x comma 5. So this will return the fifth order derivative of the above function. Okay. So here is, you can see this statement. Okay. This statement. This is the first statement. Correct the symbols. Then enter. And now we are taking the derivative. See, here the function is involving two variable. Okay. By default, if you are not defining with respect to x or y, then it will, by default, it will take with respect to x. Okay. Or either you can use like in this way, x comma f comma x. So the derivative of this one and this statement will return same. Okay, by default it will take with respect to x, but if you need with respect to y, then you have to enter y at this place. Only then this will return partial derivative with respect to y. So here is also some more examples, and you can do, we can check yourself. And this is the another way also. Sometimes you need mixed partial derivative. Okay, the thing is, in the MATLAB you can enter 3 argument one time. So if you need to differentiate with respect to x and with respect to y, first with respect to x, y, then you will take with respect to x. Okay, diff and with respect to x. So this is the mixed partial derivative with respect to x as well as with respect to y, and its partial derivative will be equal to 0. So here are the examples for the integration. f is equal to this is the function and this is the int function. To integrate, you will use int. Okay, so the integration of this function will be x by 2 minus sine 2x by 4. Okay, but in any computing program, you are using any software like MATLAB, Mathematica, Maple, R, Python, and when you will do integrate, so constant of integration for indefinite integral will not be appeared in any software. Okay, so whether it is a definite or indefinite, so in the case of indefinite, we have this value, but constant of integration will not be appear in MATLAB. Sometimes if the function is involving 2 or 3 variable, you have to define. So here you can see f is equal to x raised to power n plus y raised to power n, x, y, and n is any parameter. And when you will use this statement or this statement, by default, this will do integrate with respect to x if you are using this one. So this statement or this input value both have same sense as we do in the partial derivative. Okay, so when you will enter this statement, the integration of this will return at this place. And if you want to integrate with respect to y, then you have to enter this statement and it will return the integration in MATLAB this value. If you want to integrate with respect to n, you can do also. Okay, here is integration with respect to n. Okay, so when you will do integration with respect to n, so x and y becomes now any parameter in symbolic form, and you will have the corresponding answer. So this is the input statement, this is also the input statement, and this is the answer. So all these are entire content of the MATLAB. So here sometime if you need to integrate integration 1 to 10, okay, here we are assigning the values or the interval. So this is 1 to 10, and when you will enter, we have the piecewise continuous function. Answer will be in this form when you will enter this statement. I think I should present one more example for the definite integral. CLC, if you are using Sims, X space Y and then enter. F is equal to, we have is, F is equal to, you can take sine X plus we have is X product Y. Okay. And we want int, here is F comma X. Just 1 minute. Just 1 minute. Integral. Yes. Okay, so this is the syntax for the same. Okay, you can use this syntax. So this is the example of a definite integral. You can use integral. Okay, this is the function where which is this type of function is known as anonymous function. You can define in one line. you can define in one line. And you want to integrate the value you want to integrate from 0 to infinity. So this is the integration of the same from 0 to infinity. INF is used for infinity. Okay, this will compute the value for the function which is 1.9475 something. Okay, so these are the corresponding syntax which you can use for derivative and integration. Many examples are introduced on the slides. You must go through all these, and tomorrow we will cover some part of these slides also. Okay, here is simplify function are there, substitution function are there, plottings are also there. All these will help you in many ways. So the some part of the symbolic mathematics is missing, which cannot be covered. Time is about to 5 p.m. Okay. So what you will do, you will cover all the power presentation which I share with you. Only I was able to present 2 slides. If you will have any problem, you can discuss tomorrow before starting the session. If you have more question, please feel free to discuss with me. So the symbolic part which we discuss here is very quite simple. Just you need to define the symbolic variable and how you can use. This is important thing. And
Hello, sir.
all these are
Hello.
very helpful for mainly when we solve differential equations, integration, derivative, system of equations, system of differential equations, and many problems are there. So for that, we have to define the symbolic variable, symbolic functions, and then we can manipulate them. Yes, please now open for discussion. So now you want to ask something? Yes, ma'am. Kavita, ma'am.
Sir, is audible.
Yes, ma'am, you are audible.
Uh, for optimization or concepts, is it possible to apply this MATLAB technique? Which software is easiest for solving operation research problem like simplex technique, transportation problem?
For optimization, MATLAB is better software. All type, many friends who are working on optimization techniques, they are using MATLAB. Also, MATLAB is user friendly. We can easily get some examples. Many programs are there. Okay. And here also, when you will enter on the MATLAB or some stuff is required for optimization technique, but depends upon the problem, which type of problems you want to solve, whether these are optimization techniques or some other problems. But all type of optimization techniques we can use MATLAB and easy to use because the syntax in the MATLAB are very simple as compared to Python. Python is also there. You can use for the all type of computing. But the thing is, Python little bit typical as compared to MATLAB.
Okay, sir, thank you.
Hello.
MATLAB is very simple to use.
Okay, sir, thank you, sir.
Hello, sir.
Hello.
Yes, sir. Yeah. Uh, I'm audible, sir.
Yes, sir. You are audible, Snower.
Sir, I have a question. How to solve system algebraic equations using Sims?
Okay. I have provided power presentations. You must go through. And if you are not able to solve the system of equations, then we will discuss tomorrow. Did you check all these PPTs which I uploaded in the WhatsApp group?
Yes,
Because
yes.
I was late to share all these files. I think I upload all these file about after 3 p.m. Okay, you have less time to check all these files. The question which you are asking from me, answer is available in these PPTs.
Okay, sir. Okay, sir. And
Yeah,
system,
I
system,
think this would be a second or third PPT. You will get the answer.
okay, sir.
And the PPTs which I share with you are very quite simple. I prepared so that if you will only go through, you need not require any kind of help, even uh, which I am presenting. Those are very simple. Okay. So when you will go through, you need not require help from me. All the syntax and the explanation are given in the file. Just you need to go through, copy and use, and then choose your own example.
Okay,
Just
sir. Okay.
understand the syntax. Very simple. But for the entire symbolic mathematics, these power presentations are very helpful for everyone. Okay. And if anyone who are not familiar with MATLAB, even those people can understand.
Okay, sir. Thank you.
Yes.
Thank you, sir.
Any more question, please?
Hello, sir.
Hello. I was waiting
Yes,
for your question.
sir.
I was waiting for your question.
No, it's not a question per se. You did say that towards the end of this session, I should remind you about
Yes,
the
yes,
complaint I made
yes,
earlier on.
yes, yes. I understand. I understand.
Thank you.
Yeah. I will catch you after this lecture.
Thank you.
Yeah. So I think everything is fine. I should close this session now.
Okay, sir.
Yes, sir.
Thank you all. Yes, please. Yes, anyone asking something? Is there any question? Okay. I think no question. And I am going to end the session now. Thank you very much to listen me carefully. Good night from India.